Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at lesson 7.1.6, which some people might consider to be 7.1.5 part 2. This is where we start really getting into the benefits of using strategies to change our fraction and decimal coefficients into integers. And we are going to use this process called fraction busters to get the job done. So before we get too far into it, let's make sure that we understand the whole idea of least common multiples, or in the context of fractions, least common denominators. Least common multiple is the lowest product of two or more factors. So if I were to say take two fractions, 1/2 and 3/4, least common denominator of those two fractions, I would start with number 4 and list the first few multiples of the greater denominator, and then check to see, all right, does 2 go into 4? Yeah, it actually does. So 4 would be our least common denominator, and we can change this to 2/4, and this keep it as 3/4, and then we can do work with it. If we take these two fractions, 2/5 and 3/4, and once again start with the number 5 and do your counting sequence for 5, and then check every one of those along the way. Does 4 go into 5 evenly? No. To 10? No. 15? No. Yes, it goes into 20 evenly. So 5 and 4 share 20 as a common multiple. So that would be your least common denominator. And so this would become 8 over 20. This would become 15 over 20. If you have 3 of them, it gets a little bit trickier. So I always recommend starting, as we did here, with the greatest denominator and do a counting sequence with your greatest denominator. In this case, 6 goes into 12, and then 18, and then 24. And 4 goes into 12 3 times, and 3 goes into 12 4 times. So 12 would be our magic denominator that we would use here. So we would change each one of these fractions. This one would become, what is that, 4 over 12? This would become 9 over 12, and this one would become 2 over 12. And now you've got all of them as the same denominator. Equivalent fractions, but now with the same denominator instead of different denominators. So this idea of looking for the least common multiple of the denominators, or the least common denominator, is an essential part of fraction busters. All right, so in this lesson, you will continue to develop strategies to rewrite a complicated equation into an equivalent equation that is more familiar and easier to solve. So let's get started with problem 63. It says, oh, did I not cover something up? Hold on for one moment. Let me check. Okay, we're good. I covered it up. I just copied it down. All right, so let's get rid of that. Sherry volunteers over the summer in a veterinarian's clinic. The doctor has told Sherry to determine the correct dose of medicine to give the cat Sweetie, who weighs 9.5 pounds. The dosage for a 9.5 pound cat is given by X in the formula below. Okay, so 2x over 3 plus 4 over 3 equals 10 over 3. So we need to help her rewrite this with integers so that she can figure out what X is more easily. So what we need to do is copy down this equation. Then we need to figure out what number could we multiply times every single one of these terms in order to rewrite this equation as an equivalent equation that no longer has our denominator. Now, let me actually back this up for a second. Let me go here, let me go here. I want to make something absolutely clear. I feel like we've done this before, but I want to reiterate it. If I have the equation x plus 4 is equal to 10, we all know x is equal to 6, right? Because 6 plus 4 is 10. Okay, if I were to multiply this entire equation times 2, you would have to multiply every single term times the 2. So it would become 2x's plus 2 times 4 is 8 equals 2 times 10 is 20. So these two are what we would refer to as equivalent equations. And the way that that works is I might not write it down, but you have to make sure that every single one of the terms on the left side of the equation and every one of the terms on the right side of the equation gets multiplied times the 2. And the reasoning for that is this. If we consider the left side of the equation as a group, you would have to send in the dive bombers, right? And so if we had multiple terms on the right side, you'd have to multiply each one of those times 2 as well, because this is an example of distributive property. Okay, so with that in mind, we have to determine what number are we going to multiply times each one of these terms to get rid of our denominators of 3. And if you said, well, since they're all the same number, if we multiply everything times 3, what we're effectively going to do is turn this into 6x over 3, which becomes 2x. This will become 12 over 3, which will become 4. And this will become 30 over 3, which will become 10. So in essence, by multiplying everything times 3, you're able to cancel out the giant ones that are created, the 3 over 3, 3 over 3, and 3 over 3, and rewrite this equation as 2x plus 4 is equal to 10. And now everybody knows how to solve this problem. First, we're going to subtract 4 from each side, because we want to know what the 2x's were equal to before we add the 4 in, so they must have been equal to 6, and 6 plus 4 is 10. And then we're going to divide each side by 2, because we want to know what was the x before we multiplied it times 2. If 2 times x is 6, then 6 divided by 2 will give you the value for x, which is 3. Now, we just did a lot of steps there, right? We started off with a complicated fraction equation, and we boiled it all the way down to a single solution for x. We could have made a mistake in any number of places. So we need to check to make sure that our solution is correct. So I'm going to rewrite the original equation before we did the fraction busters, and then I'm going to substitute our value for x wherever it belongs in the equation. So instead of 2x, it becomes 2 times 3. Well, that becomes 6 divided by 3. And if you add straight across, because we've got common denominators, 6/3 plus 4/3 is in fact equal to 10/3. So that proves that our solution for x, being 3, is correct. So what does that mean? She needs to give a dose of 3 milliliters. I guess I should have put that in. X is going to equal 3 milliliters for Sweetie the cat. All right, so now let's examine this equation. X over 4 minus 5 over 6 is equal to 7. Please copy that down. We just multiplied every single term times 3 in the previous equation. So let's do that again, but this time let's choose the number 4 since x is being divided by 4, right? So if we were to do that, if we multiply everything times 4, then we're going to get, this 4 is going to cancel out with that 4, but what's going to cancel out with the 6? 4 doesn't cancel out with 6. That doesn't form a giant 1. So we're going to just have to multiply the 5 times the 4, and sure, we could simplify that to 10 over 3, but still, the whole point of multiplying everything times a multiplier is so that we no longer have to deal with fractions, but we still have to deal with a fraction there. So what happened when we multiplied everything times 4 is only the 4 got canceled. The 6 didn't get canceled. Now, let's actually try the same thing here, but this time let's multiply everything times 6. Now you're going to be able to cancel out the 6 here, but still, it doesn't cancel the 4 out, so you're still left with a fraction that's attached to your variable, and it's still a complicated mess to try and solve. So we have to come up with some sort of a strategy for how we can multiply every single one of these terms times the same number that will effectively cancel out both the 4 and the 6. Why don't you think about what that multiplier might be? We'll pause for a second to give you a chance to think about it. All right, have you thought about it? The 4 and the 6. Remember what we talked about at the beginning of this lesson, the idea of a least common multiple or least common denominator. What could you multiply times every term that would not only cancel out the 4, but would also cancel out the 6? If you said 12, you got the least common denominator or least common multiple. If you said 24, that would technically work too. Actually, any multiple of 12 would work. You can multiply everything times 12, times 24, times 36, times 48. But for purposes of what we're doing, I think 12 is the best number. That's going to keep things as easy as possible. So let's go ahead and do the process. It's all modeled based on what we were showing here, but now we're going to be able to multiply everything times 12. Okay, so go ahead and see if you can find the solution for x by working through this process. All right, let's see how you did. If you multiply 12 times this, literally that becomes 12x divided by 4. Okay, so you could do some cross-canceling there, but sometimes students prefer to write it this way. And now 12 divided by 4 is equal to 3, right? And 60, that becomes 60 divided by 6. And this doesn't have a denominator, so we're just going to have to multiply the 7 times the 12 with nothing canceling out. So that's going to become an 84, but this can become a 10, and that can become 3x. So multiplying everything times 12, we rewrote this equation as 3x minus 10 equals 84, which looks a lot easier to solve. So now once we're here, if you had trouble getting to this point, but now you feel comfortable, go ahead and pause and see if you can get to the rest of the answer, and then unpause so you can see the reveal. I'm just going to move forward, okay? So depending on whether you want to just work along with me and copy me down, or if you want to try and figure it out on your own, I'd recommend you try and figure it out on your own, because that's going to show you that you know what you're doing, okay? So pause if you wish, otherwise I'm moving on. Okay, so we're going to add 10 to each side, because remember, 3x minus 10 is 84. I want to know what the 3x's were before I took away the 10. They must have been 94, because 94 minus 10 is 84. So if 3x's is equal to 94, what do you multiply times 3 to give you 94? Well, take 94 and divide it by 3, and you'll find out, it turns out it gives you a repeating decimal. Or if you wanted to write it in fractional form, you could say 31 and 1/3. All right, this looks like a horrible problem to try and check. 31.3 repeated divided by 4 minus 5 over 6. That sounds horrible. We could do it with your calculator, but I'm going to introduce you to an idea that a professor in college showed a class once that's called the ballpark method. Do the ballpark check. You don't necessarily have to check 31 and 1/3 divided by 4. You could round that up and maybe say, could we call it about 32 divided by 4? And 5/6 is really close to 1. So does that get us pretty close to our answer? Yeah, it does. And a lot of times when you do the ballpark method, you end up getting like 6.97 is equal to 7. And it's like, yeah, okay, well, I rounded. So if I would have gotten something really wrong, it would have been like -5 is equal to 7. Those are way apart. They're not even close. But if using the ballpark method, if you're rounding these numbers to make it easier to check mentally, if you end up seeing that it gives you something that's really, really close, like within a few hundredths or maybe a tenth of the correct answer, then you probably got everything correct and you can feel confident. Now, worst case scenarios, you get it wrong, but then if you hadn't checked it, you would have gotten it wrong anyway. So you might as well use the ballpark method and see if you can't feel a little bit more confident about your answer. This is, in fact, the correct answer. All right, so this process is what we call fraction busters. Okay. The method you used in problem 64 to eliminate fractions from an equation can be called fraction busters, because the multiplication of the equation by a common denominator or several of the common denominators eliminates or busts fractions. The result is an equation that has no fractions. So Sherry's now attempting to solve this problem. Please use fraction busters to figure out our answer. But before we do, take a look at those 3 denominators. What do you think is the best number that could be used to eliminate all 3 of those denominators? Go ahead and write down a little statement. What is the common denominator for these fractions? Write down what you think. Well, we don't have to. You probably have it figured out already, don't you? Let's just go ahead and give the reveal. 6 would be the best one, right? But you could use 12 if you wanted to. For that matter, you could have used 18, or you could have used 36. You could use any multiple of 6. That would have worked, but 6 is going to be the best one. So go ahead and work through the process, see if you get the answer. All right, so the first part of the process is figuring out your new equation. So we decided 6 would be our multiplier. So when we multiply everything times 6, this becomes 12b over 3. This becomes 6 over 6. This becomes 6b over 2. And now you simplify. 12 divided by 3 is 4. 6 divided by 6 is 1. 6 divided by 2 is 3. So it becomes 4b minus 1 equals 3b. And I really hate it. I'm just going to go on record right now. I hate it. Hate them putting the variable b in the same equation where we've got 6's. It looks like 36. Can we just stick with x's and y's and w's and t's, the kinds of variables that you would never confuse with a number? It's just ridiculous how they do this, but whatever. I'm over it now. All right, so what is the equation? That is the equation that we're going to work with. So go ahead now and solve 4b minus 1 is equal to 3b and check it to make sure that you got your solution correct. And can I just state, when you check it, you cannot check it in this one. You've got to check it in the original. If you made a mistake going from here to here and you check in this equation, you're not going to catch the mistake that was made. You've got to always go back to the original equation. Okay, so go do that, and then unpause when you're ready for the reveal. All right, let's see how you did. Take our 4b minus 1. Let's add 1 to each side. Oh, look what I did there. Sneaky. I did 2 steps in 1. I knew that this was going to form a 0 pair, and this was going to form a 0 pair. Why not just do it in the same step? Let's add 1 to each side. Actually, let's not do it that way. Let's add 1 to each side so that we can cancel out these guys. And let's add or take away 3b's from each side so that we can do these guys all in the same step. So this 4b minus 3b gives you 1b, and 1 is 1. So our answer has to be 1. So there we go. Shortening it up. This is a good strategy for you guys to start using. Now that you're comfortable with the idea of whatever you do to one side, do the same thing to the other, adding or removing balanced sets, you technically added a negative 3b plus 1 to each side, so that made them balanced sets. So let's check. If b is equal to 1, then it should be 2 times 1 over 3 minus 1 over 6 equals 1 over 2, right? Yes. I forgot to put the parentheses around this guy. Technically, I like to put parentheses where the variable used to be, so I know that I've got everything filled in properly. So 2/3 is the same as 4 over 6, right? And 4/6 minus 1/6 is 3/6. Is 3/6 the same as 1/2? Yes, it is. We're good. We've got our answer. B is equal to 1 for this equation. All right, so back to Sherry and the cat, Sweetie. Sherry is worried that Sweetie is too thin. The doctor tells Sherry the weight of a typical cat like Sweetie is given by W in the formula below. A healthy cat will be within 2 pounds of whatever our value for W is. And I was a little confused about this problem until I went back and reread the original problem. And here's Sweetie, she weighs 9.5 pounds. So we're trying to find if her current weight is within 2 pounds of what we're going to get for our value for W when we solve this problem. Okay, so first off, what will be your multiplier when you look at those two denominators? What is your common denominator going to be? What would your multiple be in this situation? Go ahead and copy this down, multiply every single term times your multiplier, your least common denominator, and rewrite the equation, then solve for W, and then determine whether or not Sweetie is too thin by comparing the value of W to 9.5. Okay? Take your time, work through this, and unpause when you're ready for the review. Alrighty, let's see how you did. So did you determine that your multiplier was the number 10? That's what it should be. Now, I'm going to show you a slightly different approach. I like the fact that you're multiplying times 10, but I also like the idea of factoring the 10 out. So this 10 is going to cancel out with this 10, so I'm totally fine with us. What do I want to do here? Writing the 10 in here because that's going to cancel out the 10 completely. But here, we aren't, what are you going to multiply times W? You can say 10W divided by 5, but what if we just cancel out the 5s, and now that leaves us with 2 times W, and here nothing cancels out. So by expanding this one out so we can see that you're canceling out a 5, but you're leaving a 2 to be multiplied times the W, sometimes that's helpful. Sometimes students like doing it this way instead. It's total preference, whatever you'd rather do. If you'd rather just write 10, 10, and 10, and then this 30 over 10 is 3W. This is 10W over 5 is 2W, and this is 5.5 times 10 is 55. Do that as well. All right, so now you're going to combine like terms, and then you're going to divide by 5, and you're going to get an answer of 11. All right, now let's make sure that that is the correct solution. Let's take our original equation and plug in our 11s. 3 times 11 is 33. I did a little shortcut there. 11 over 5 is equal to 5.5. I'm going to change this. So it's 22 over 10, so we can add those together, and you get 55 over 10. 55 tenths is the same as 5 and 5 tenths. That is correct. So we now know that the cat, or W in this case, is 11, and the cat is 9.5. So that's within 2 pounds, right? That's only 1.5 pounds light. And so is Sweetie too thin? No, Sweetie is not too thin. Being 11 or being 9.5 pounds is within 2 pounds of W, which is 11 pounds. All right, now we're not going to do all of these. This one is crazy. I do want us to first start off. Please copy down A and B. And I want you to identify what is your ideal multiplier to multiply times each one of these terms, here and here. And I want you to identify what your multiplier is here, but we're not actually going to solve for x because I don't want us to take all this time in doing it. We can get everything we need to do here in parts A and B, okay? So start by copying everything down, or these two down. This one, see if you can figure out what your multiplier is going to be. And then we'll solve for A and B. Take your time, maybe 10 minutes or so to work through all of this. And you should check your solutions, but I'm not sure. Are we going to check ours? I'm not sure if I'm checking them or not. We should, but I don't know. We're going to run out of time. Okay, I'm pausing. Give you a chance to work. All right, so to begin with, 6 and 3. Those are our 3 denominators. So I'm going to pick the biggest one. And I'm going to just do a counting sequence. Does 4 go into 6? No. 3 does, but 4 does not, so that cannot be our multiplier. 12, 6 goes into 12, 4 goes into 12, and 3 goes into 12. So we're going to make this our multiplier. We're going to multiply everything times 12, and I'm going to go ahead and separate it out like this, okay? So when separating it out like this, 2 times 6 times 5 is going to give you a total of 60 over 6, which gives you 10, right? But if we want to just cancel out, no, that's not what we're canceling. We got to cancel the 6 out. So that leaves you with 2 times 5 is going to give you 10. This is going to cancel out the 4s, which leaves you with 3 times 11, which is 33. And this one will cancel out the 3s, which gives you 4 times 17. Go ahead and use your calculator. You'll see that that is 68. Now, 10x plus 33 equals 68 is a much easier equation to solve than that one. So now we'll subtract 33 from each side. We'll divide by 10, and we get a solution where x is equal to 3.5. Go ahead and check it. I guarantee that's going to work. Problem B. 6, 12, and 8. Let's start with the number 12. If 12 is the number that we're going to use for our multiples, 6 goes into 12, but 8 does not. So 12 cannot be our multiplier. Then you go up to 24. That's the one that works. 6 times 4 is 24. 8 times 3 is 24. So we're going to make 24 our multiplier. So 24 times x over 6, 24 times 1 over 12, 24 times x over 8. But I'm writing them in expanded form because here I'm going to cancel the 6's, leaving you with 4 times x. Here I'm going to cancel the 12's, giving you 2 times 1. And here I'm going to cancel the 8s, leaving you with 3 times x. So this becomes 4x equals 2 plus 3x. Now subtract 3 x's from each side, and that leaves you with 1x on the left, so x is equal to 2. That is going to be our solution. This one would be easier to check. I would assume you're going to check it to make sure that it works. It does work. All right, this one I promise you we're not going to do. But we have to start with 15. Does 3 go into 15? Yes. Does 5 go into 15? Yes. Does 9 go into 15? No. 15 does not work for our common multiplier. The next multiple would be 30. 3 and 5 go into 30, but 9 doesn't go into 30. So the next multiple would be 45, and that's the one that works. 3 times 15 is 45. 5 times 9 is 45, and 9 times 5 is 45. So 45 would be the multiplier that you would use. You would rewrite it, solve for x, and then check it, and you would have your solution. Now, we can go in the other direction as well. Remember, this is a long lesson, okay, but hopefully we'll be done before 30 minutes. You can do fraction busters in the other direction as well. I don't know why you would need to. Just use your calculators and add a 1,500 each side, then divide by 300, and you're done, right? But technically, it works in both directions. So if I divide everything by 100, I can change this to 3x minus 15 equals 24. And that just looks a little bit easier, doesn't it? Add 15 to each side. Then take, what is that, 39 divided by 3, and you end up with x has to be equal to 13. And then when you check it, 300 times 13 is 3,900. And if you take 3,900 and subtract away 1,500, you get 2,400. So that proves that that is correct. Here, you could do the same thing, but honestly, I would just add, maybe I would add 6 r's to each side and take away 36 from each side. But, you know, maybe it's easier to do it this way, where you just add 2 r's to each side and then take away 20 from each side. No, 12 from each side, and that leaves you with r is equal to -6. You can prove that that works by plugging in 3 times -6 is -18. 36 minus a -18 is 36 plus 18, which is 54. On the right side, if we plug in -6 here, that becomes 18 minus 6 times -6, which is minus a -36, which is the same as plus a positive 36, which is also 54. So there you go. Okay, so I'm not sure that I'm endorsing this. That just looks like more work to do when it's really not that complicated. But here, I can't speak enough how effective Fraction Busters is for solving problems like this, okay? And like I said, Fraction Busters starts by you identifying the least common denominator of your fractions. You would do that anyway if you were just keeping them as fractions and working through the normal process, right? If we were to subtract 11/4 from each side, you have to get a common denominator, which was 12, and rewrite those as equivalent fractions so you could do the subtraction. And then you would still have to do a little bit of multiplying times reciprocals and all that jazz to get to an eventual answer. So all the processes of common denominators and multiplying and whatnot, it ends up being the same set of steps, just in a slightly different order, in a slightly different way. But students like this the best. I like it. CPM likes it. I would practice this whenever you get a chance. It makes it much easier to solve. All right, let's move on. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.